Thanks for coming. My name is Tony. I'm a software engineer working in Appier. And in this talk, I'm going to share lessons learned from migrating to a Stateful Streaming Framework. And here is my outline today. First, I will introduce Appier and our use cases. And the second, I will show my Flink job that on production, migrating from micro-batch framework. And the last two parts, I will show which are the major parts of this talk, sharing my experience during the migration and my challenges after I changed the design in streaming way. And let's talk about Appier. Appier is a technology company that provides AI platform for our customers to solve their business problems. One of my successful products is advertising platform. As you may know, there are many use cases in advertising industry, such as user retargeting, fraud detection, and so on. Our AI system provides many machine learning models to solve more than these topics. One important component in this AI system needs to extract pattern quickly from streaming data. And that's what I'm working on by leveraging the power of Flink. And next, I will show my first production job, a dynamic rule service on Flink. This is the original design of this system. There are two parts in this system. The first part is implemented by micro-batch framework. It will read rules from the internal service and use those rules to apply on those streaming data from Kafka, and then output the result to external service. And the other part is batch pipeline. It has the same logic as the micro-batch pipeline, but it will trigger when user create new rules. Those new rules will apply on those old data from a long time ago as a bootstrap step to initial result on external service. So that because those data was too old to not retain in Kafka anymore, we will read them from S3 bucket. There are some disadvantages from micro-batch framework, such as high latency, back pressure, and inconvenient to maintain states, because we want to support exactly once on our states. And there are new requirements for this system. We want to support more stateful rules, because in the previous design, our rule only focus on the current events, but not including the historical states. Such as we want to find the user that view website twice in the past week, or some user viewed the products but didn't buy it. So here comes our new design on Flink. There are three differences between the previous one. First, we use Flink, of course, to support more stateful rules. And second, we decouple the pipeline with external service by using Kafka, because we want to use different consumer groups to serve each external service. In the previous design, they are all mixed into the pipeline and make the latency as high as the most time-consuming one. And third, we need to use batch pipeline to rebuild the states for Flink streaming pipeline. Because we didn't want to store all combinational of states in Flink, it will be huge and not necessary. So we need to rebuild them when new created rules that need the new states. And this is the detail of my job graph, since it is built on Flink 1.4, so we didn't use key broadcast pattern. And the first, thank you. The first part, we use state rule to retrieve the state information from our event log. And in enriched states, we store that states and enrich the events. Also, the rebuild states will be applied in this operator. And finally, we use pattern rule to find the pattern from enriched event and send to the Kafka. And these are improvements after migrating to this new design. about performance and cost efficiencies, because the change not only including migrating to Flink, but also including some refactoring. But using Flink really let me support more rules of stateful rules and make good use of our machine resources. And next, I will share my experience during the migration journey. The first tip I learned is reading documentation and mailing list. And all we know that this is the first step to learn a new thing. But some people always read Quick Start or Basic API, then turn to work on their applications. In my experience, I read lots of internal architecture design, and that made me have more clear picture that my job run on Flink, and prevent me from making too many common mistakes. However, it is quite hard to read all documents, and my suggestion is to subscribe mailing list and read those topics that you are interested in. In one of my experience, I had learned a lot from those problems that users have had before in mailing list. One example is this configuration. I read that on mailing list. It solved the problem when text manager was kicked off by job manager. All I need to do is add this config and use supervisor to protect my text manager. By the way, this is not the problem after Flip 6 came out. And next tip, prepare monitoring tool and alerting tool, like previous speaker said. I built this because Flink has its metric system. I use Prometheus, Reporter, and Grafana to build them. And like this is my Flink job metrics. I use them to investigate the problem when my job failed. Also, we have the status of my Flink cluster. Besides Flink metric system, I use Prometheus node exporter to expose more detail of my machines, such as disk I/O and disk usage. I once had a problem that checkpoint failure almost once a week, but the problem just disappeared after I cleaned up the cluster and restarted. After I installed node exporter, I noticed that it is due to too many log files that occupy the disk capacity. It is a stupid mistake, but it let me know how important to have a well-prepared monitoring tool. And next, after my job went on production, I focused on those important metrics and build alert on them. They make me react the problem if my job failed. For example, I use this alert to check checkpoint alignment, which took too long to align the barrier, or check the text manager if its GC ratio is too high. Not every alerting was set in the first time. Some of them was created after I made the problem, faced the problem, and noticed I should be aware of that. And the final tips I learned is be familiar with your environment and your Flink job. There are two case studies I want to share in this tip. The first case is about EBAs. This is the link from Flink user mail list. It was talking about I had a problem that there are checkpoint bottleneck when uploading the file to S3. In the end of this discussion, I noticed that because I misunderstood the performance of EBS, and the downgrading of uploading is due to I ran out of the IOPS quota of EBS, so the uploading will be downgraded. So in my case, I choose to use local SSD instead to solve this problem. And the second case is I had a memory resource problem on my Flink job. In this picture, you can see there are many colors, each them represented of one attempt of a retry. So you can see my job just failed and restarted frequently. And also, the Kafka consumer throughput was unstable too. In the beginning, I guess the problem is caused by memory problem because it's by network issue. Because I found lots of timeout problem in my log files, such as Arca Hobby timeout or Kafka producer timeout or Zookeeper session timeout. But after I attached JState on my text manager, I found that it is due to high garbage collection ratio that brought down my Flink job. So in this case, we choose to scale out my Flink job to get more memory resource, and everything went back again. Okay, so the last part, I will share the challenge after I changed the design to streaming way. These challenges are still open questions to me, even though I already had some workaround solution for them. The first challenge is to rebuild states to Flink because the data was not retained in Kafka anymore. So we need to retrieve the data from S3 bucket, but we should guarantee the exactly ones after I change the source from S3 to Kafka. And the second is we want to expose the match count of each rules. It is not suitable for Flink metric system because the amount of rules is dynamic and then change from time to time. It is better to use queryable state instead. But in my opinion, it is too expensive because we need more space to store these states. But all I need is just a metric count. And the third challenge is end-to-end verification. It is not only including the end-to-end test on my Flink job, but also including when user create rules on internal service and use batch job to bootstrap, and then the states rebuild on the Flink and use those states to match the pattern on streaming data. All this we should put together and verify the correctness and tell user that their rules was created successfully. So to recap my talk today, the first, I want to show how important to read documentation and mirror list carefully. And second, monitoring tool and alerting tool help me respond to the problem quickly. And third, be care of your environment and Flink job because stateful streaming is environment sensitive. And finally, don't forget to call for help from community and prepare your sufficient information from your login and your monitoring. Thank you.
Thank you very much. Are there any questions?
Thank you for your presentation. How did you reuse, if any, did you reuse your job code between stream and batch for the replays?
For reuse the code or?
I mean, did you use the same? Did you write a job for dataset API and one for the data stream API?
For my case, I didn't use dataset API for this part. I use the batch job. We also use. We still use Spark job, but we decouple the framework and the operator, and use those operators both on Flink and Spark. So we have the same logic for these two parts, but we will change the source on batch job and streaming job. So we need to, so it is still difficult to ensure the executive regularity. So we need to have some trick out of this.
Okay, thank you.
Any more questions?
Great talk. So I noticed you were monitoring a lot of like checkpoint metrics, checkpoint alignment, and that kind of thing. Can you talk a little bit about some of the issues you saw with checkpointing that caused you to start monitoring those metrics?
Please, I'm not really know what your question is.
Oh, yeah. So I noticed you were monitoring a bunch of checkpoint-related metrics,
Yes.
like alignment, checkpoint alignment bytes, and number of times or how long it took to complete the checkpoint and that kind of thing. I was just wondering if that was related to any issues you had with checkpoints or errors that caused you to want to monitor those specific metrics.
For checkpoint barrier, we didn't really had some problem. But for checkpoint, we have many problem like uploading, I mentioned in the previous case. So for barrier, we had the problem only when back pressure is too high. But that is the problem about my job to replay too many old data from Kafka. Yeah.
Any more questions? If not, thanks again.